Oh, that's.
What?
I think we got it.
Oh, okay. 4x squared dx 2 pi antiderivative x to the 5th over 5 minus x to the 4th plus 4/3 x cubed. Do we agree with the antiderivative? Yes, we're good?
Yeah.
And then last but not least, the fundamental theorem. 32 fifths minus 16 plus 32 thirds. We? Can I really expect you to add fractions without a calculator? Yes, I can. Common denominator is 15. What did you multiply this first one by? 3. What's 32 times 3? 96. Cool. What did you multiply this second term by? 15. What is 16 times 15? 240. How'd you do that? Just out of curious. How does your mind work? Multiply by 5 and then multiply by 10 and add it?
I wrote it down.
That's weird. See, I would think 15 times 15 and then add another 15, but add a 16, but whatever. Okay, and what is 32 times 5? 160. Okay, 2 pi. So we got your 256. Take away 240 is 16/15. So our volume is 32 pi over 15, yeah? How'd we do? All righty. Okay, this is a really gigantic lesson. It's 2 days, probably 3, maybe 4. It's most of this chapter right here, differential equations. So, here we go. Are you ready? Okay.
All right.
So, here's the deal. First of all, it's hard to do separable differential equations if you don't know what differential is. So let's define our terms first. A differential is what Leibniz called the infinitesimal. It is a very, very small change in a variable like dy and dx. It's the microscopic delta y and delta x, or delta whatever, d whatever. It doesn't have to be y and x. You with me?
Yeah.
So when you hear differential, think dd something. You down so far? Cool. A differential equation then is any kind of equation with those differentials in it, with a dy, a dx, or both. Now it's often the case that we actually see dy dx, which is to say, so you mean a derivative is a differential equation? The answer is yes. A derivative is a differential equation. Now, that said, I'm saying a derivative is a differential equation when you're using Leibniz notation. So that's a differential equation. That's not a differential equation. There's no differentials there. You with me? Okay, so it's partially a notation issue, but with writing it with differentials or Leibniz notation, gosh, so many things you can do with it. So here's the deal. You'll often be asked to solve a differential equation, and that right there, the vocabulary there is a bit problematic because I've had more than one student, this has happened maybe 3 times. You'll do gobs of these, dozens of these, and yet I've had 3 students on the AP test get the free response that says solve the differential equation, and they didn't know, they froze up. They said, what does that mean, solve the differential equation? So just so we're clear, when I say solve the normal equation, what are you doing when you solve it? You're finding the x that satisfies the equation, that makes it true, yeah? When you solve a differential equation, you're not finding the x that makes it true, you're finding the equation that makes that derivative true. Okay, so when you solve a differential equation, you're really finding the original equation. You're undoing the derivative. Is that clear? So if, for example, we look at this as I go through my notes here, if I asked you to solve this differential equation, then that really means I want the original yx equation that derivative came from. You follow me? You with me?
Yes.
Now obviously then, that involves integrating. And you might be thinking, I don't understand. You've been integrating forever. This is not new. Yeah? Well, it's a little new. Yeah. First of all, it's not like just straight up this. There's more to it than that. First of all, the differentials here. This, what is it? Plus C. This, what is it? Plus C. This, what is it? Okay, so despite the fact many of you are total weasels who leave off the differential, do you agree that the differential matters? Because it tells you the variable. Yeah? All right. Now, that said then, this, a differential equation, not often, every time is going to be split. You're going to split the differentials because you're actually going to be integrating both sides to this. So the very first thing you do, and the most important step in terms of AP points, is you separate the variables, all right? Now when I say separate the variables, that means put y's and dy's together on one side of the equal sign, and x's and dx's together on the other side. Now depending on what the equation looks like, the algebra could be different. Depends on the equation, but the algebra is never super duper hard. So if you separate the variables, then you would get y dy on one side of the equal sign and x dx on the other. That's separating the variables. You down? Now, it's important that you do that because you're about to integrate, and when I say integrate, it's rules of math. You must integrate both sides. You can't integrate one side. So when I go to integrate, it has to be both sides. Well, I can't integrate two sides unless I have differentials on both sides. I need to know what I'm integrating with respect to, and that means you need to have differentials separated so you have two differentials to work with. What is the antiderivative of y dy? Y squared over 2, okay? Plus a c. I'll call it c1. And when you integrate the right, 1/2 x squared, or x squared over 2 plus c2, because you have a constant on each side. Follow me? Now, just so we're clear though, I could, say I combine the constants. It's arbitrary, c1, c2, c whatever. I could subtract c1 over and get y squared over 2 equals x squared over 2, and I could call that new constant c3, for all I care. You with me? Are you with me?
Yes.
Okay, now write yourself a note here. Because the constants, did I write this over here? I did. Okay, I want this added in here. See, because the constants can be combined, we never do this kind of work. We usually just put a single constant on one side. I wanted you to see the idea that really, technically, I get a constant on both sides, but it's arbitrary, and I can put them together in the next step anyway. So we don't show that. We don't show that C1, C2, C. We don't do that. We just say put a C on one side. I don't care which side, but there's got to be a constant on one of the sides. You with me? All right. Thankfully, then we don't have to show that every time because that would be tedious. All right. Now that is called the general solution. The general solution is really a family of solutions. I talked about this the very first day I taught integration. If I said y equals x squared plus 1 y equals x squared plus 2, y equals x squared plus 3, all of them have the same differential equation or derivative. What is dy dx for all of them? 2x, yeah? Now, when we go backwards, without knowing a little more specifics about what the equation's like, really we have just a family of solutions. And rather than call it family of solutions, we have what's called the general solution. So the general solution is just a bunch of possible equations without knowing the C. You with me? Okay, cool. Now, if they give you a point on the curve, then that rules out lots of possibility and nails it down to one possibility. When you find the C, you're finding what's called the particular solution. All right, so say I built off of this problem. I said, given the curve also passes through 2, 4, find the particular or one single solution. I'll put in the initial condition. Being careful to put the 4 and the 2 in the correct places for x and y. Okay? If I do that, I get 8 equals 2 plus c, so c is 6. That implies that y squared over 2 equals x squared over 2 plus 6. That's the particular solution. You follow me? Is this going okay? Okay. All right. Last but not least, depends on the book, but definitely on the AP test. Sometimes they want you to then solve for y. They will express it then this way. They'll say, find the particular solution y equals f of x. Now, this implies two things, actually. This statement implies two things, and it's subtle. First of all, you must solve for y. Second of all, your answer should be a function. Okay, you may be thinking, okay, so what? Well, here we go. If I take this equation and solve it for y, then I would, let's do it slowly. So let's say we move the 2. So y squared is x squared plus 12 if I move the 2. You follow? All right. Now, when I square root, it's plus or minus square root of x squared plus 12. Yay? All right. Now this is not okay. Because although it satisfied the first condition, that I solved for y, it doesn't satisfy the second condition, that y is a single function, passes the vertical line test of f, of x, sorry. So I must choose positive or negative to make it a function. So that when you put in an x, there's no, oh, y could be this or y could be that. It's y is this, period. All right? So how do I choose? Just what you feel like or what you think will look pretty in front of the equation? How do you choose? On the initial condition. It must make the initial condition. So in this case, it has to make the point 2, 4. Now, the only way that's going to happen is if y is the positive branch. The negative branch would give me a negative y, and that's supposed to be a positive 4. So I would say something like, because of 2, 4, I'm going to choose positive. That communicates to the person, I did the algebra correctly. I know it's plus or minus, but I'm consciously choosing the positive. Now on the AP test, if you fail to put positive or negative and then consciously choose positive, you don't luck out and get it right. In fact, you miss 2 points. One for not knowing the algebra and one for not demonstrating which branch you need to choose. All right? So they don't give you points for luck. You must know what you're doing. Is this making sense so far? Any questions? Excellent. Let's try another one then. This is more like, now these are always on the free response on your exam. You'll get one of these for sure. And there are a lot of points. They're usually 5 points, and that's a lot in a free response. Very rarely are free response parts so many. And they're really soft. 3 or 4, usually 4 of the points are really easy to come by, and the last point's a little harder. But this is layup time, baby. You'll rejoice in these if you see these on the test. You'll say, yeah, I can do this. All right, so here we go. Consider the differential equation. Find the particular solution, y equals f of x, to the differential equation with f of 1 equals negative. Let's do this together, but you tell me what to do. What should I do first? Find the original. That is the whole question. Yeah, so that's the question. Now what do I do first? That's the first step. Separate the variables. Separate the variables, all right? So when I put the y's and dy's together, what do I get? dy over y. Now you can see that the algebra is not always the same, right? We cross multiplied the first one, but that's not always what you do, okay? In this case, I divided y over, moved the x dx over, and you get dy over y is negative 2x dx. Do you follow? All right, cool. Now what do we do? Integrate. We're going to integrate. Whatever you do to one side, you do to the other. You may do that at the same time you separate, and that's fine. What is the antiderivative to the left? Natural log of absolute value of y. Now that absolute value is super important because if you don't put it in there, first of all, your antiderivative is wrong, but second, you're going to be basically out on at least 2 points to come because you just made the problem easier if you don't have it. What about the right side? Negative x squared plus, and then we're going to put a constant on either side. And again, I don't care which side, but it's typical. I typically put it on the x side. Are you with me? And that's most people. All right. Now use the initial condition. I'm going to go off to the side and use the initial condition to find the c. First of all, because it's good point strategy, but more importantly, it's just easier math to do it first. All right. So negative 1 goes in for y. You can see how that if we didn't have that absolute value, we'd already be in trouble, yeah? Natural log of the absolute value of negative 1 equals negative 1 squared plus c. So what is c? C is 1, yeah? Natural log of absolute value of negative 1 is log of 1, which is 0. So if I move the 1 over there, I get c is 1. You follow? All right, so I'm going to go back to where I left off and put in that c. Log of absolute value of y is negative x squared plus 1. Everything going so far, so good? All right, cool. There's one more easy step, and then things get wacky. All right, so what do you do next? Am I done? Did I find the particular solution? Okay, I did, but did I find this part? That part I have not done. Okay, the particular solution is done because once you find the c, that's the exact one case solution done. But it does imply that you want to solve for y in function notation, so we have more to do. So here we go. How do you solve for y? Exponentiate. So if I exponentiate the absolute value of y, students want so desperately to say, all right, well, forget that absolute value. When you exponentiate, that gets rid of the log, not the absolute value. The absolute value is still there. All right? You follow me? All right. Side note, side math lesson. If I said the absolute value of y is 2, what would that imply? Y would either be positive or negative 2. Do you agree that either one of those would make that true? So when you lose absolute value, when you, quote unquote, dump absolute value, it's plus or minus. It could have been either, and we'll have to investigate that further. So when I say the absolute value of y is this, that means y could have been either the positive or the negative version of this, and the absolute value would have been e to the x squared plus 1 either way. All right, you cool? Now we have to choose. Well, which one should we choose? If y is negative 1 when x is 1, that's the initial condition. Y needs to be negative 1 when x is 1. And based on the initial condition they give me, then we must choose the negative. Y is negative e to the negative x squared plus 1. All right. Are you tracking so far?
Yes.
Okay. Anybody have a problem with this answer? If you were to check your answer, what would you say? So let's check. If y is negative e to the negative x squared plus 1, how would I check that I did this right? Take well, I could use the initial condition and make sure it passes through that. That's true. What about, how do I check the derivatives right? So if I take the derivative, so this is what cooped me out, because I'm a super critical, I think you screwed up teacher kind of guy. I was an arrogant jerk like that. But I said, wait a second, when you take the derivative on that, what's the derivative on that? Negative e to the negative x squared plus 1 times negative 2x, right? Well, wait a second. When I take the derivative on anything, I get something like this. Not that. Did I do something wrong? Yeah. What is this equal to? This is equal to y, yeah? According to my answer. So if I put in a y here, does it actually look like it? Yeah, it does. Okay, so sometimes by substitution of the equation into the differential equation, it does check. It's true. Okay? All right. Would you try just find the general solution first? Let's get that skill. Try to break this into little skills, all right? So do the first three, please. Feel free to confer with your math amigos, although this part's not very hard, I don't think. This is really just A, can you separate variables? B, can you? Yeah. So you just integrate. I don't care about finding the C. I don't care about solving for Y. Just integrate. Separate the variables. My heart agrees with every word is made for you. Are we ready? ¿Listos? ¿Sí estamos listos o no estamos listos? ¿Sí? Sí. Okay. Maddie, what'd you get for separated on the first one? What's your separation?
dy equals dx times 2x.
Okay, love it. I agree. Do we all agree? Okay, and what was your antiderivative, Kelsey? X 3 halves x squared plus 2x plus c, is that what you said? Plus, it's 2x, right? Okay, cool. All right, do we all agree? Cool. Harrison, what'd you get for your separation on the second one?
dy over y squared plus y equals 2dx.
Love it. And what did you get for your antiderivative, Monica?
I got the inverse tangent of I equals 2x plus c.
Agreed. Well done. We all agree with that one. Hi. Thank you. Any questions on that bad boy? Martin, what's your separation on the third one? Okay. Brian? Drew my attention.
dy over 3y squared
Okay.
equals dx over x.
Love it. Good job. Okay. Now, it's important to know that the 3 as a constant, you could have two different possibilities. Some people say I left the 3 on the right side. Some people say I moved it with the left side. Just know it's not attached to the y. It doesn't have to go with the y. It could stay over there, okay? It's not. You with me? So either way, it's fine. If you do this bad boy, remember your good power rule basics? This is the power rule, not a law. It's very common that people will say, you know, anytime you see a fraction, there's a log going. No, that's not the case. Okay, it's just when it's to the first. So what is the antiderivative of y to the negative 2? Negative y to the negative 1. Remember, we raise the power by 1 and divide by the new power. So that's negative 1/3 y to the negative 1, or if you like, negative 1 over 3y. And that's if you move the 3 over with the y. If you kept the 3 on the right side, then you'd get something else. But it's fine, it'll look the same on one side. All right? What about the right side derivative? The antiderivative. Natural log of the absolute value of x. Let's see. All right. The first step, separating the variables and integrating, going okay. Okay. Now let's practice separating the variables and then finding the plus c. So would you do part B, please? Love is all that I can give to you. Love is more than just a gift to Did you get something like 2 natural log of the absolute value of x plus 3? Okay, you're on the right track. If not, then look at what you did and try and figure out what you did wrong before you go on and do more. I'll be walking around. I'm sure if you have questions, let me know. It doesn't say solve for y yet, so you don't have to solve for y. Okay, last part. Just finishing up, it looks like. Ms. Brown, for the second one, what'd you get for your separation of variables, please?
Y squared dy is
I agree. Okay. Abby, what'd you get for your antiderivatives for the second one?
1/3 y cubed equals 2 now.
Love it. And after putting in 1, 1, what'd you get for your plus C? Yeah? 1/3? I agree. Okay, so 1/3 y cubed equals 2 log of absolute value of x plus a third. You follow on number 2? Okay, cool. Andy, what'd you get for separation of variables on the last one?
e to the negative x dx equals 2y.
Okay, I agree. And your antiderivatives here. Maggie, what did you say in your antiderivatives? Awesome. Did you actually use something or just kind of guessing something? Works. Okay. And what'd you get for the C there, Andrew? -3. Do you all agree for -3? Okay, excellent. All right. -3. Last but not least, the job of, oops, there's more, right? Oh, yeah. Okay. The plus, the whole kit and caboodle, basically. This is what a 3 response often has, is the whole thing, including solving for y and choosing a function, right? So try the last part. finish it up. Okay. Okay. Jake, what's your separation for the first one look like? Okay, I like it. I think it's easier to leave the two where you did, the way you did that. Sounds good. Tyler, what's your antiderivative there?
Y squared over 2 equals 2x.
Got it. 2x plus c. What'd you get for a c? Miss Harrington, what'd you get for a c on the first one? What'd you say? 21 halves. Do we agree? Okay. I haven't done any of these yet. So y squared over 2 equals 2x plus 21 halves. Are we done? Speak to me some vocabulary. What have we found there? That's the particular solution, but we did not solve for y yet. So I think you'll agree that when we solve for y, we have y squared equals 4x plus 21, and y is positive or negative square root of 4x plus 21, yeah? And yet we have to choose. How do I choose whether it's positive or negative so the answer is a function, not a plus or minus case? Yeah, based on the initial. I want y based on the fact that I'm supposed to pass through 1, 5. The only way that I'm going to do that is if I choose the positive version. And again, remember, be intentional. Is that what you got? Okay, cool. What's your separation look like? Sarah, what did you say for the second one? Awesome. So, oh, sorry, I cut you off. Go ahead. Okay. So obviously secant is in the denominator, but that's terrible. And so it is awesome to call it cosine of y dy equals dx. Upon integration, is that sine y or negative sine y? So confusing. Is it sine y or negative sine y? Sine y, yes. Okay. The derivative of cosine is negative. The antiderivative is not negative. Sine y equals x plus c. Finding the initial condition, sine of pi over 2 is 1 equals 3 plus c, so c is negative 2, so sine of y is x minus 2, so y is the arc sine of x minus 2. And that does check out. Arc sine of 1 is pi over 2. Okay, we're cool. Last but not least, your separation. I think I got everybody. Did I get everybody? All right. Jim, haha. Forgot you didn't see that. Okay. What is the separation, please? All right. And this one's all you, buddy. Keep going. Oh, well, that's all right. We can do it now. Okay. And now what do we do? Okay, so sometimes C is kind of crazy. In this case, it's a weird looking C. C is negative 1 plus natural log of 4. You follow? All right. Natural log of the absolute value of y is x minus 1 plus log of 4, or vice versa. So absolute value of y is e to the. When I e this, is it e this, e this, e this, or e the whole? It's e the whole thing, and it is different, all right? And last but not least, y is plus or minus e to the x minus 1 plus log of 4. And I choose. What do I choose? Choose positive. So y is e to the x minus 1 plus log of 4. So, last thing. On the multiple choice, your answer won't look like that. Your answer might look something like that? How?
The natural law?
Okay, so think exponent rules first. What's x to that? What is x to the a plus b equal to in terms of exponent rules? It's multiplication, right? So this is e to the x times e to the negative 1 times e to the log of 4. Yeah? Now these don't simplify much, so it's better to just probably keep them together. But this simplifies. Yeah, that's 4. And so you'll often see that happening if you're seeing that. All right?
Corey Rickman is not. Corey Rickman is just another year added to his existence, which sucks for you.
Isn't that true?
Corey Rickman
Sucks
was
for
like
you.
reading books. He's doing them.
Are you just reading that? How long have you been in that seat?
I just saw that poster and I didn't
There's a
know.
lot of good ones.
I didn't know you were on the next test.
No, that's PC. But actually, maybe for you too. So, seniors, are you getting a bunch of stuff from Miss McSkinney saying you can't undivided?
No. Yeah, I am in regular. So no.
One more thing, sorry, I don't want to make you late. I want to put the answers to last night's homework on my website. Will you check them tonight so tomorrow we can get caught up a little? And can I get 87A today?
Yeah.
Okay, 87A is due, 87B is not due. Is that understood?
I don't drink caffeine.
You have a long way to go in your teacher's class. Have a great day. Thanks, you too.
Michael.